Welcome! Today's lesson is on conservation of mass. As a lot of you probably already know, conservation of mass is one of those theories that allows us to be able to predict what will happen in a reaction. For instance, conservation of mass tells us if you start with a certain amount of reactants on one side, when it goes to the reaction, you should be able to recoup the same amount on the other side. So if you start with 4 grams on the reactant side, on the product side, you should also have 4 grams. We're going to be testing that theory out today, and let me introduce you to the players. First of all, we're going to get into this packet. This little effervescent tablet is Alka-Seltzer, and we're going to be weighing that in just a moment. The other player in our scenario today is this. This is vinegar, 5% vinegar. We're going to be taking 35 mLs of this, which has acetic acid in it, and we're going to put it in this graduated cylinder. And our last player is, well, the Lazy Cow glass. Some of you have frequented the place, so we've invited our Lazy Cow. And no, he's not a sponsor of today's video. But anyway, what we're going to do here is we're going to measure everything, and then you're going to go to your Google Slides and fill in that table that you can record all of those weights, all those masses. So the first thing we're going to do is we're going to first of all turn this thing on. And as we go through this process, I'd like you to go ahead and write them into that PowerPoint or slides. First of all, we're going to put the tablet on here, the Alka-Seltzer. And it says it's 3 grams. As you see the 3 grams up on the screen, make sure you record it on your Google Slides. Number 2, we're going to put 35 mLs of vinegar into this graduated cylinder. So let's do that right now. And being careful, whoops. All right, 35 mLs. Now we're going to take this, and now what we're going to do is we're going to pour it in our Lazy Cow glass. Make sure we get every little bit of it in here. Set that off to the side. Make sure we set that off to the side as well. And now we're going to measure how much this thing is. And wow, Lazy Cow, you need to go on a diet. Ooh. It's 413 grams. So let me show you a quick little video of that so that you can record it in the Google Slides. If you take a look at your Google Slides, you should have the mass of the Alka-Seltzer at 3 grams. You should have the mass of the cup and the vinegar without the reactant yet, 413 grams. So the next thing that we're going to do is we're going to take this tablet and let it react with the acetic acid. So here we go. Let's take a close look at it. All right, here we go. 1, 2, and 3. Go. All right, we're back. Now, if you take a look at this, you can see that it's pretty much done. I'm just going to give it a quick little swirl and make sure that all of the, if there are any reactants left, they will react with the acetic acid and kind of fizz out the last piece and parts of it. Okay, so at this point in time, it is now finished. So we're going to go ahead and take this off for just a second. I want to go ahead and turn this back on, and then we're going to re-weigh it and see what happens. All right, here we go. It's 415 grams. We had a mass of the Alka-Seltzer was at 3 grams. Then when we looked at basically the mass of the vinegar in the cup all by itself, we had 413 grams. So altogether the reactants as well as the Alka-Seltzer and everything else put together was 416. Now, once we put the Alka-Seltzer in here and let it fizz out, we ended up with a total mass of 415. 416 before the reaction, then at the reaction, 415. Did you eat it? Explain inside the Google Slides presentation what you believe the missing components went. In addition to this particular lab, to be able to explain why we're missing some of the mass. Conservation of mass kind of depends on a closed system to be able to gather everything. So actually what left? That's right, the CO2 left, exactly. So, I'd like to do the whole thing over again, but this time, let's put the cap on it. Do this, but I'm going to do a lot faster. We know that that's 12 grams, and we have another Alka-Seltzer tablet. We're going to weigh that, and it says 3 grams again. All right, our next step in this process is we're going to, first of all, I'm going to take this thing off, and then we've already poured the 35 milliliters of vinegar. I'm going to pour it in our Lazy Cow jar, and then we're putting a lid on it. And now I'm going to mass it, and that mass is 400 grams. Yeah, 400 grams. So the next step is, okay, remember we're trying to close the system to capture all the products. So we're going to drop our Alka-Seltzer in, and this we're going to sit back and just wait for a moment for it to all fizz out and to have that reaction take place. So now the products are going through the reaction, and that should be in just a few minutes. So we'll get right back to you. All right, as you can see, it's still a little cloudy, but all the fizzing's gone, and it looks like all the reactants have of course reacted, and so we're done. So let's go ahead and measure or mass this, and according to this, it's 403 grams. 403. Now let me just go over the measurements again. Make sure you put it in your Google slides. 3 grams for Alka-Seltzer. For the jar as well as just the vinegar, that was 400 grams. Then what we did is we added this to this, that made it 403 grams. And then when we had the total mass of the jar, the vinegar, and these reactants, it came up with a grand total of 405 grams. We had 403 before the reaction, 405 after the reaction. So it gained 2 grams. Because of this is now a closed system. It's captured all the gases, it's captured all of the products, and nothing was released. Whereas the first one, the lid was off, and obviously all of those reactants that were gaseous, like the CO2 and the oxygen, they escaped, and that was just 1 gram. They lost 1 gram, whereas this one gained 3 grams. So there you have it. What we'd like you to do now is go back to your Google slide presentation and fill out the questions as well as the analysis. Thank you for watching today, and staying to the end of the video. And we'll see you next time. We'll see you in the lab.